Now I'm going to add equal amount of water in the 3 beakers.
Good afternoon, students.
Good afternoon.
Today we have 3 experiments to perform, all of them on solubility of substances. The substances that we'll be working on are displayed over here. We have this is sugar, sucrose. This is from local market. Here we have ground F, hoping we'll extract as much starch from it. And here we have common salt, table salt, which is sodium chloride. It has come from the supermarket, so it is iodized. Here we have ground sugar. We're going to see if that will make a difference in solubility between the ground and the unground sucrose, sucrose, sugar. This is not, of course, a physical process. We're going to see if sodium, which is kept under paraffin, we'll take just a piece of it, drop it into water and see what happens to it. From the outset, I would like to assure you it is not a physical process, it's a chemical reaction where sodium metal reacts with water to form sodium hydroxide and release hydrogen gas. We'll try to see if the gas really pops, which is the test for hydrogen. But over here you have a glass where the ground F has been dissolved in water because the F has husk, which is mainly cellulose, that is water insoluble, and I'm trying to filter to get something richer in the starch, which is water soluble, more soluble than the cellulose. Starch is not very soluble like sugar or sodium chloride, but it's more soluble than cellulose. We don't have to go to the details of the chemistry, why cellulose is less soluble, or we can say insoluble in water, whereas starch to some extent is soluble. Here we have baking powder. I just brought this from Belgium. It is sodium bicarbonate. It works for generating carbon dioxide that helps make the bread softer and spongy. It replaces yeast. This is fresh, so we hope it will look better. Over here is lemonade. It's extract of lemon. We're going to see how we can make it sweeter by adding one of the solvents, the solutes, in this case sucrose. So you take over.
Okay.
Hello, Liu.
Hello, Radit.
What are we going to do today? Doctor has already explained the materials that we are going to use for our experiment, but to remind and to be specific, what do we have here?
Today we're performing experiments regarding the solubility of substances, what affects them, that is the factor, which can be temperature, surface area, or using a stirrer. That's what we're going to do.
Okay. In addition, solubility is affected by temperature and pressure, the characteristic, the chemical nature of the solute, and the chemical nature of the solvent.
Yes.
So what do we have here?
Okay, here we have 3 beakers, a lemonade, and a normal sugar, which we buy from a normal market, and a ground sugar.
This one, it means?
Yes, I think this one is the brown sugar. And we can feel the texture because it is soft.
Okay, in order to stir, we are going to use a simple spatula and another spoon. So can we start our experiment?
Yes, the first step is adding equal amounts of lemonade in each beaker. How do you open this?
I think enough for you.
Shall we add more?
Yes, and the middle one.
Yes. Okay, that's all. So why did you add the water?
Okay, before that, let's take out the seed. Can I have a spoon? I don't think it can help me.
I think we need this to add a sugar in, so.
So we need to wash the spoon.
Okay. Maybe we can use a spatula.
Okay, let's try. Liu is taking out the seed. There's no seed.
I'll be taking out it.
This is squeezed lemonade.
Okay. We're fine to go.
Now I'm going to add equal amount of water in the 3 beakers. I think nearly equal.
Now next, the core part of this experiment
What is it?
is adding sugar. First, I'll add this normal, not ground sugar, to the first beaker. I'll add 2 spoons equally in each beaker.
What about in the third beaker?
I'll just add the ground one.
We have added 2 spoons of sugar in the 3 beakers. What's next, Liu?
Next, the first part in the core of this experiment, I'll stir the first beaker. Using a spatula, it's okay.
Liu is stirring the solution.
It's almost done. So, what difference do you see between the 2 beakers?
I think in your beaker you have stirred the solution, so the sugar has almost completely dissolved. And in my beaker, I didn't stir the sugar, and still there's suspension, which I mentioned before, because I haven't stirred sugar, and it has characteristics of suspension, but it's still dissolving. And the third one, compared to this, it has dissolved, but there's still suspension.
Yes. Which has similar characteristics.
Yes.
As suspension.
So here we have procedure. I didn't mention it before. How does stirring affect how fast sugar dissolves?
The way that stirring affects is that when you stir, you're distributing the sugar molecules to the lemonade uniformly, so the solubility rate increases and the sugar dissolves.
Okay, I think as you said, because of that, I didn't stir the solution in my beaker, and this one, because of collusion, still there is suspension. What about in this beaker?
In this beaker, as you see, what do you think I did?
You ground the sugar.
Yes, I added a ground sugar into this lemonade. When you ground the sugar or any substance, you reduce its size. So in that case, its surface area per volume ratio increases, so that more collusion occurs and the sugar dissolves faster than the unstirred and ungrounded.
So in order to compare the three beakers, why don't we stir the two beakers?
Yes.
I think that's already stirred one.
No, that one is the stirred.
There's still suspension, so this one is not stirred.
I'm impressed by the explanation you gave, but it could be a bit confusing because there are numerous variables here. The amount of the volume of the solvent, the mass of the solute added, the temperature, and also the agitation for stirring. How do we know the effect of one of them unless the others are controlled? Do you have questions on this slide?
Well, I have a question. You added equal amounts of water and lemonade to the beakers. What would have happened if you had added different amounts of water or lemonade?
Can I answer your question? If we put a different amounts of solid and the water amount, we wouldn't have seen the effect of stirring and the surface, the change in surface area of the sugar we used here.
And in case of the solvent, if we put, for example, if we make one of the beaker, this has sheer amount of water, and we reduce the amount of water in one of the beaker and add some amount of water larger than the other beaker. As the solvent increases, there is a probability of dissolving the solute increases because there is the amount of solvent is greater than the amount of solute, so there is higher probability of dissolving the solute. But in our case, we used equal amount of water, almost equal amount of water. Did we answer your question?
Any questions? Can you now define what solubility is?
Okay, solubility is the amount of solute dissolved per 100 gram of the solvent. And in solubility, there is a solvent, and a suspension. A solute is is the substance that dissolves in the solvent, and the solvent is the substance, or mostly it's liquid, that dissolves the solute. A suspension is when the solid does not dissolve and there is precipitation.
I would like you to be clear on 3 points here. There is difference between solution, which is a homogeneous mixture, and it is clear if it's liquid. You can have colloids, can have also suspensions. Suspensions and colloids are not solutions because they are not homogeneous in nature. So a solution, if it is in the liquid state, has to be clear. Even if you use light to detect particles, you will not be able to see anything.